That should work. I always feel very important with the microphone. Hello, everyone. I'm very happy on behalf of the group to actually start this session. My name is Nicolas. I'm French. I have a background in actually pharma finance. Who is going to speak right after me has a background in management and is our local representative from Portugal. And we have Julius from the Netherlands with a background in pharma science. So as you can see, it's very pharma-like, and our project is around pharma. To give you a bit of context for those of you who are a bit less familiar with the field, we wanted to give you some insights on what it takes to actually develop a medicine to the market. For a successful molecule to reach the market, what it takes is actually time and money. It takes around 300 million for a successful molecule and 10 years to reach the market. This is actually only one side of the picture, because as a patient, what we usually don't see are actually all the failures that happen along the way in the development pipeline, and those are a lot. And if you integrate this cost to the successful ones, it means that one big pharma company needs to invest 1.2 billion to get to one successful molecule because of all the ones that failed on the way. So for the pharma company in general, the strategic imperative for them is to detect the failure early in order to be able to reduce this 1.2 billion. It's not only important for the investor, of course, because of the money. It's important for the pharma executives so that they can reallocate the budget to the molecule that are likely to have best impact. And ultimately, it's important for the patient that will benefit the treatment at the end. Considering the high-stake problem and question, we came up with a core question. And the core question was, with machine learning in mind, of course, can we predict, and how much can we predict, which clinical trials are most likely to fail or to succeed, even before the trial is starting? And this is the important part, with only starting information from the trial. It didn't start yet. And you might think that, okay, it's all about science, so science might be random, you don't know, they are specialists in science, but actually clinical development, you need to know that it's a lot more than just science, because there are many decisions that need to be made on the way to design the clinical trial, the therapeutic landscape, the competition, the patient recruitment. When you have a clinical trial, you need to define the rules for the patient to enter the trial, which makes it sometimes very difficult, and the sponsor track record, of course. And out of the huge database that we had, we identified 113 variables that we feed into our model in order to get one prediction of success of the clinical trial or actually the failure. And to tell you more about the approach that we had, I will let...
Okay, thank you, Nicola. Well, this slide shows the machine learning workflow for our project. Our project, it was a three-step approach. The first step was the preparation of the data. The data preparation means that we had to extract, to transform, and to load the data into a format that our model could use it. We started with the AACT database. It's a public database which has more than 500,000 clinical trials. And after cleaning it and selecting the information that we needed, we ended up with 80,000 clinical trials. Then we had to create new features on our model and aggregate them in 4 categories. This was to make the prediction more understandable and more easy to read. Step number 2 was the choosing of the model of machine learning to predict whether the clinical trial would be a success or a failure. After testing several models, we came to the conclusion that the XGBoost would be the best model to our project because it was the most reliable and the most consistent in terms of results. Then we moved on to step 3. Step 3, uh, sorry, was the getting the predictions. But getting the predictions wasn't a straightforward path. We had to go back to our data set that we prepared and retrain the model, fine-tune the model several times until we felt comfortable with it, and until the model reached the standards and the metrics and the performance that we established. Then we introduced a new layer of interpretation called CHAP, because it was important to us to make a prediction, but it was also important to us to explain why we get to that prediction. Finally, we build up an interface user to make the interaction between the user and the model easier. Okay, Nicolas?
Yes, and where did that actually bring us in terms of scoring? So how good were the prediction? So if those scoring metrics are a bit confusing to you, or to some of you, that's normal. It's actually called the confusion matrix. So no wonder. So basically, to put it simply, the dark blue is basically the well-classified successful trial and failure. The main score that we looked into is called ROC-AUC score, and we reached 70%. And basically, to put it in simple words, what it is, if you have one clinical trial that will be successful and one clinical trial that will fail, if you choose randomly, you have 50% chance to choose it right. And in our case, the model is actually helping us to predict the failure with 70% chance. So we break the odds. The thing is that we looked into was, when we had this score, it was okay, what is existing on the market, what is our benchmark? And with a public data set, the industry standard is to reach above 70. So we were actually a bit lucky. We reached 70.2. And in MIT, the gold standard that was established in 2019 is above 78. Okay, we are not in MIT yet. If we keep working on the on the model for one more week, maybe we can improve, but maybe not there yet. But we are still hopeful.
So now let's get to the fun part. I will show you the dashboard we've been building over the last 2 weeks. So this is the dashboard, and in the dashboard you have a search bar where you can type in the ID of the clinical trial ID, or you can use the drop-down function, which is part of a database which includes every ongoing current clinical trial at this moment. And then you can select one, so let's do it. And then when you select one, you get all the information about this specific clinical trial. So first you have the title, the phase it's in, the therapeutic area, and you can use the drop-down to get some more specific information about the trial. And then when you're confident this is the trial you want, and you want to make a prediction on, you can press the Make Prediction button. So let's do it. And then you get the prediction dashboard. And this tells you first the score of the probability that it will be successful or not. So for this clinical trial, there is a high chance of it being successful. But that's of course nice to know, but we also want to know what are the reasons of the model thinking that it will be successful or not. So as Rui told us, there's 4 categories which we grouped all the features in, and then we calculated what are the contributions of these different groups to the success or the failure. And as you can see, for this specific case, patient and criteria is the most contributing factor to the success. So we can dive deeper into this and look at the driver's map to find out the reason of the model. So let's look and check it out. What the model tells us that it's hard to read, but it tells us that the patient condition status suggests easier recruitment. So probably for this clinical trial, the recruitment was pretty easy because they have less criteria, which obviously helps for succeeding in the clinical trial. Then we can check, of course, what are the criteria for a specific clinical trial. And we'll see that they are looking for healthy volunteers, which are always easier to find. And they're looking for adults, which are also easier to find than children or older people. So the recruitment was easy. So this probably contributed to the success of the clinical trial. Now let's do another one. So again, you get the information of the clinical trial, and then you can make a prediction. And you get the prediction dashboard again. And for this clinical trial, the chances of succeeding are very low. And there are some other reasons for this clinical trial. So you see now the sponsor and operations are the main factor deciding that it's probably going to fail. And secondly, the patient and criteria. So then again, we can look into the driver's map and see what are the reasons. So we're first going into the sponsors and criteria, and then we'll look for the reason. And then it says in small that probably the sponsor track record may be less established, or that the sponsor is prone to frequent strategy changes. So that doesn't help the clinical trial, of course. Then we can also look into the patient criteria, and then we'll see that they probably have complex criteria for the recruitment. So it's like the other way around. And then we can look into the design again of the clinical trial, and then we see they only want sick people, which are often hard to find. And if we look into the criteria, they have like a long list of criteria which the model interprets as complex, which makes it think it's hard to be successful. Then we, of course, wanted to check, are these reasons that the model found really the reasons for failing or for succeeding? So what we did is, for this specific clinical trial, we knew it was going to terminate already, and we knew the official reason it was going to be terminated. But the model sees it for the first time, so the model had no idea. And then we can compare the reason of the model to the official reason. So let's check the official reason. And it says no statistical analysis was performed, as only one subject, so only one patient was treated with the medicine, and the sponsor decision to discontinue the study. So if we look down, it's the sponsor and the patient, so the reasons align. So this really shows how powerful this tool is in predicting the clinical trials, which of course, if you start up a clinical trial, could save you a lot of money and the investors, and also help a lot of patients. So we really want to thank Le Wagon and all the teachers involved for building this cool tool. So thank you.